I know that you guys are more than capable of solving equations once we get them down to those simple two-step equations that we've been practicing on all year long. So my goal today is really to take larger, more complicated equations and simplify them down to those simple equations that we know how to solve. While doing that, there are going to be two key points that we're looking out for today. Two big general ideas about how we go about doing this. So as we look at our first equation here, we see that it is not a simplified, normal two-step equation. Something x plus something equals something. We don't have that going on here. We have a little bit more to this one. So the way that we're going to go about doing this, the first thing that you're always going to do is you're going to look at each side of the equation individually. So I'm going to start by looking at the left-hand side of the equation. I'm going to ask myself this question. Is this half of the equation, this side of the equation, simplified? So, Kip yes or Kip no. Is this a simplified expression, 2x plus 4? Is there anything I can do to simplify this, 2x plus 4?
Yes.
Mauricio, what do you think we can do to simplify 2x plus 4? We could, but I don't really see how that simplifies the expression. Not to mention, it's an expression, so we can't really do any operations like division without thinking about the other side of the equation. So there's nothing we can do here to simplify this expression. That's as simple as it gets. 2x plus 4. We can't combine those terms because they're not like terms. So now we're going to flip over to the other side. We're going to look at the other side of the equation. 5x minus 5. Kip yes or Kip no. Is there anything that we can do to simplify this side of the equation? Kip yes or Kip no. Is there anything we can do to simplify this side of the equation? I need 100% participation, otherwise we are not going to be moving forward as quickly as we need to be. Kip yes or Kip no. Is there anything we can do to simplify this side of the equation? Some of you are saying yes and some of you are saying no. Somebody who's saying yes, tell me what you think we can do to simplify this. Haseen. Change switch. So change switch is actually making it less simple because it's now having two operations. However, this is a step forward if we want to go ahead and solve this. So I'm not going to say this makes it simpler, but this is something that we're going to want to do if we're going to go ahead and solve this. Okay? So those of you who said no, we're absolutely right. Those of you who said yes and were saying yes because you wanted to leave change switch, that's fine. Okay? So since we have both sides simplified, now we need to figure out, the second part is saying, hey, how do I get my x terms together? Okay? What can we do to go ahead and move our x terms so they are together? What kind of operation do you think we ought to do here? Christopher? Yeah, I want to do the additive inverse. And so what do you want to add to both sides, Christopher? Okay, he's going to add a -2 to both sides, and this is totally okay. I don't imagine that this would be what most of you would want to do, though. I would imagine most of you would want to do something slightly different, which would be totally accurate. What's another way we could have gone about doing this, getting those x terms together? Joel? We cannot use the commutative property across an equation or across an equal sign. So we cannot just move the 5x over to the other side. Remember, when there's an equation, we have to use inverse operations. That's the only option we have. However, what is another way we could have gotten our x terms together here? Francel? Yeah, we could have added the opposite of 5x. We could have added -5x to both sides. And for a lot of you, you're going to find that to be more comfortable because you like to have the x's on the left-hand side of the equation. That's totally fine. The choice is up to you. As long as you are getting the x terms together, it doesn't matter which side of the equation you get them together on. So on this particular way, we're going to get them together on the right-hand side. Jordan, question? Why does it look so long? So we are adding an extra step of work in there to get it to be a little bit more simple. And sure enough, oops, after we get that step of work done and we can work it out, it is a little bit more simple than it was before. A regular two-step equation. This is where we're going to stop for today because I know you can solve this equation. I don't want to waste our time worrying about solving equations today. Today's goal is really working with more complex equations and getting them to the point where I know you know how to solve them. So we're going to stop on this step here. Okay, so looking at the next equation. Again, a little bit more complex than the one before it. First thing that we need to do is look at each side of the equation individually and say to ourselves, is there anything that we can do to simplify this half of the equation? Kip yes or kip no? 100% participation. Is there anything we can do to simplify this half of the equation? Excellent. I see almost everybody showing me kip yes. Noemi, what can we do to simplify this half of the equation on the board? Add what? Add 5x plus 3x. So we're combining our like terms here. Can we combine the negative 2? Can I go ahead and add the negative 2 in there as well?
Nope.
Kip yes or kip no? Can I go ahead and add the negative 2 in there as well? No, I can't. That's not one of our like terms. So we can combine these two like terms. 8x plus negative 2. Because we can't combine that unlike term in there. Kip yes or kip no? Is there anything else we can do to simplify this side any further? Okay, no. So now we want to look over at the other side. Kip yes or kip no? 3 minus 2x. Is there anything we can do to simplify this side of the equation any further? Okay, see pretty much everybody showing me no. What's the one thing we are going to want to do with this side of the equation so we can move our work forward though? Edwin? Yeah, change switch. So now that we've got everything taken care of, let's go ahead and make sure that we've got the whole equation as it is now. So that just means we're going to have to end up rewriting that line. No big deal. It took me about half a second to get it done. And now that we've got both sides as simple as possible, we need to get all of our x terms together. So what is it that we need to do to get our x terms together, Haseen? Okay, so Haseen wants to add a positive 2x to both sides, which means he's going to get all of our x's on the left-hand side, which I imagine is most comfortable for the majority of you. When I look at changing an equation and getting my terms on the same side, I usually try to get them so they're all positive. So I don't always pick left-hand or right-hand side. So when we look at this, we're going to go ahead and negative 2x plus 2x, that cancels out, leaving me just the 3. Combine our like terms. 2x plus 8x is 10x plus negative 2 equals 3. And this, again, is as far as I want to go today. I know you can solve these two-step equations. I'm not going to waste your time by saying, hey, let's go the extra steps to make sure we have an answer. All right, third problem. This one, even more complex than the problems before. Okay, we're going to start by looking at the left-hand side. We're going to say to ourselves, kip yes or kip no, is this side of the equation simplified? Got to listen to the question. Some of you are saying yes, because I don't think you think this is simplified. I think you think there's something we can do to simplify it. All right, so there needs to be some simplification done here. What can we do to help simplify this half of the equation? Mauricio.
Add 12x plus 3x.
Mauricio wants to go ahead and add the 12x and the 3x. However, what I'm going to go ahead and say is that we want to go ahead and commute those terms together first, just to avoid any mistakes. So I'm going to commute my terms. So my like terms are next to each other. Get my 12x plus my 3x together. now I'm going to go ahead and do what Mauricio suggested, which was combine my like terms, 12x plus 3x, and that's going to give me 15x. What about the negative 3 and the positive 2? Noemi? So Noemi says subtract them because she's seeing their opposite signs. So she's going to opposite sign subtract and take the sign of the larger number. It's negative 1. Okay? So we can combine like terms here. Kip yes or Kip no. Is there anything else that we can do to simplify this side of the equation? Kip yes or Kip no. Is there anything else we can do to simplify this side of the equation? I need 100% participation. That includes people who are trying to take a nap in the front row. Thank you. All right. Let's look on over at the right-hand side. Kip yes or Kip no. Make sure you listen to the question. Is this simplified? No, it is not. What can we do to simplify this? Patricia. Yep. Add our like terms here. 3x plus negative 2x is a positive 1x. Desiree, what else can we do here to simplify? Yep. Add the 3 and negative 4. So opposite sign subtract, and we take the sign of the larger number. We get 1x plus negative 1. There are some very small things we could do to make this more simple if this was going to be our final answer, but considering we need to move work forward, is there any other simplification we want to do here? Thank you for those of you who are answering my questions without me having to remind you, Kip yes or Kip no. Is there anything else that we want to do to simplify this side? Okay, there is not. So we want to back out. We'll go ahead and throw in our equal sign here, and we'll throw in our equal sign here. We need to go ahead and rewrite that step just so we have it all lined up in one place. And now we need to get our x terms together. This is the step that we have to be super careful with. What is it we want to do to get our x terms together? What is it that we want to do to get our x term? Okay, she wants to add a negative 1x to both sides, so she's using the additive inverse. To cancel out on the right-hand side of the equation, the 1x with the negative 1x that she has added to both sides. So we've added negative 1x to both sides. And negative 1x plus 15x, that gives me 14x plus negative 1 is equal to negative 1x. That cancels out because that adds up to 0. We get 14x plus negative 1 is equal to negative 1. And again, that's as far as we're going to go today, because I know you can solve that equation. I'm not worried about that. When we move on to the next problem, we're going to see something that's going to add a little bit of degree of difficulty, but not something that we can't handle all on our own. So again, no matter what's going on, the first thing that I want to do is look at each side of the equation individually and say to myself, is this simplified? What can I do to simplify this? Kip yes or Kip no? Can I simplify this any further? Okay, most of you are saying yes. What can we do? Michaela? Distribute. Once I distribute, I get 2x plus 8. After doing the distribution, Jordan, is there anything else I can do to simplify? No, there is not. So we'll move to the other side. Mauricio, looking at this side of the equation, is this already simplified? What can I do? Distribute. So let's do our change switch first, and then distribute. Okay. Oops. That was really quick to get both sides simplified. Now we need to get our x terms together. Ricardo, what would you like to do to get our x terms together?
Remove the 15, you turn it to a negative, so 15x, and then you put it to the other side, on the other side with a 2x, and then add negative 15.
Okay, so I hear Ricardo saying he wants to add negative 15x to both sides. The additive inverse, making sure that he's doing the same thing to both sides. So we had a negative 15x that we added to both sides. On the left-hand side, we have negative 15x plus 2x, Monica A, that equals negative 13x plus 8 is equal to negative 15x plus positive 15x. That's 0. Plus negative 5 would be negative 5. Yes, Monica? Yes, thank you for catching my mistake. I made a mistake on the distribution over here. This should be negative 25. Yes, Michaela?
Does it matter which one you do the inverse to which side?
Yeah, so Michaela asked a very important question, one that I've kind of answered already today. So let's see if somebody else can answer that question. Michaela, can you ask it loudly enough so one of your teammates can answer it and hear it for you?
Does it matter which number that we do the inverse?
No.
Thank you for calling out. Somebody who can not only answer the question yes or no, but also give a quick explanation as to why. Montana.
It doesn't matter because in the end your answer's still going to be the same.
Yeah, doesn't matter. In the end, you're going to still be the same because when we go through those extra steps of actually solving it, you're still going to get the same answer. It just doesn't really matter. Liana.
So what do you have to add like a negative instead of just 15?
Okay, so remember this is an equation, and whenever you have an equation, you have to do the same thing to both sides of the equation. So if you just commute it, that's like taking negative 15 away from one side, but adding a positive 15x to the other side. So we can't just commute it, because we have to do the same thing on both sides of the equation. Okay? Next one. Actually, let's skip down to this one. I think you guys have the hang of it. So we'll do just one more problem. And we'll look at this one. So the first thing that we want to do, as we've been doing in all of the problems, is to look at just one side of the equation first and say to ourselves, hey, is this side simplified? Kip yes or kip no, is this simplified?
No.
Gosh, I hope not. That looks really complicated. Okay? So looking at this, what is the first thing that we need to do to help simplify this particular half of the equation? Maya? Yeah, let's do the distribution, but even before that, let's go ahead and do our leaf change switches, just so there's no mistakes there. So after I do this distribution, 12x is just going to come down. He's not part of the distribution. Negative 3, he's just going to come down. He's not part of the distribution. Here we have 3 times x, that's going to be 3x, plus 3 times 2 is 6. Kip yes or kip no, are we simplified yet? Kip yes or kip no, are we simplified yet? Haseen, what do we want to do now?
You have to add 12x plus 3.
Okay, Haseen wants to combine like terms. Before we combine the like terms, let's go ahead and commute them together. And now we can combine them, and that's going to give me 15x. Plus 3. And that's as simple as it gets. So now we're going to move over to the other side of the equation. We need to get to work on simplifying this half of the equation. Noemi, what's the first thing that we're going to want to do to simplify this half of the equation?
Distribute.
Yeah, we're going to do the distribution. Remember, before we do the distribution, we want to go ahead and do those leaf change switches. So we're distributing the right things. So that means we're distributing a negative 2 over here. That's when you have to be really careful of when you have that subtraction in front of that distribution. Make sure you're distributing the correct thing. After the change switch, we're distributing a negative. 3x isn't part of it. It comes straight down. Negative 2 times negative 3x makes a positive 6x. Negative 2 times negative 3 gives me a positive 6. And the negative 4 isn't part of this distribution. It's just going to come straight down. Okay, what else do we need to do to finish simplifying this half of the equation? Liana. Louder? Yep, we'll combine our like terms. 3x plus 6x gives me 9x. And 6 plus negative 4 gives me positive 2. That's as simplified as it gets, so we'll get the whole equation involved here. Oops. So if we want to get it all together, we're just going to have to bring down what we found on the right-hand side just one more step. But at this point, we don't have all of our x terms on the same side. So what is it that we would like us to do, Marta, to get all of our x's on the same side of the equation? Okay, she wants to add a negative 9x to both sides. Negative 9x plus 15x, that's 6x plus 3. 9x plus negative 9x, that's 0. Plus 2. And again, this is as far as we want to go today. I know you can solve this. I'm not really worried about you solving this. This is as far as I need to do. Are there any questions about the problems that we've done so far? Please track Jordan for his question, and don't flip over to your together time because we're not quite ready for that yet. Jordan, question.
We're like in the very beginning of 8th grade. Are we going to be like doing this stuff? Or
Here is, before we move on to our together time work, let's go ahead and look at our key points. There were 2 key points, 2 things that we do when we're solving these more in-depth equations. Desiree, give me the first.
Simplify.
Simplify what?
Your number, your exponent.
Okay, somebody give a little bit of clarity to what we want to simplify and how we go about simplifying. Patricia? Yeah, simplify each side of the equation. Simplify each side of the equation using distributive property and combining like terms. So after we've got each side simplified, we're going to end up with a problem just like this first one that we did. So there's something else that we need to do to get it ready for our simple 2-step solving. Jalil? Yep, moving on to our second key point. Jalil, what do you got? That was realistically what our first key point was. It's kind of just a different restatement of it. So Frida, what do you think? Perfect. Use additive inverse. To get all variable terms on the same side. Okay? Any questions about any of our work for today?